Okay. Thank you. Okay, let's start, better. Yes, boys, let's start.
Law of conservation of energy. Law of conservation of energy states that energy can neither be created nor destroyed. Whenever energy changes from one form into another, the total amount of energy remains constant.
Okay, this is what we had learnt yesterday. So the main meaning is conservation of energy. What is that? That means energy is not wasted. We are conserving the energy. That that means so simple, isn't it? What is the law? Law states that neither you can create energy nor you can destroy energy. Okay? The energy remains as such, yes, but it does change from one form to another. If you club all the energy, the starting energy and the final energy, it remains constant. So there is no wastage whatsoever. Let's take an activity. Yes.
When a body is thrown upward or dropped from height, the total mechanical energy, that is, sum of potential and kinetic energy at each and every point on its path remain constant.
Okay, just a moment. Now, here is the ball. You are throwing it upwards, right? Or there is a ball over here. You are throwing it downwards. Okay? So, whatever energy from here to here and from here to here remains the same, even at every point. For example, I'm just putting these are the points. Okay? The energy remains the same. The total energy. What is the energy that we are talking about, beta? It is the potential energy and the kinetic energy. So you calculate over here and then you calculate over here, it remains the same. The total energy remains the same. The only difference will be that somewhere potential energy will be maximum and in some places kinetic energy will be maximum. But if you account it, if you club it, the value remains the same. Okay, read.
Note that at the highest point of its motion, when an energy is fully in the form of potential energy, and at the lowest point, the energy is fully in the form of kinetic energy. At all other points, the energy is
Partially.
partially potential and partially kinetic.
You understood or not? First tell me, did you understand this one? For example, here I'm holding the ball. So what is the energy? Potential energy, right? Okay. Then I drop it. It falls onto the ground. So what is happening? Potential energy is converting to kinetic energy. You agree, beta?
Yes, ma'am.
All of you? Fine. So it is converting to kinetic energy. And where it will be the kinetic energy maximum? Here. When it strikes the floor, the kinetic energy is maximum. Where was the potential energy maximum? Here. And now where is the kinetic energy maximum? Here at the bottom. Hope you have understood. The potential energy was getting converted to kinetic energy. Here it is. Got it?
Yes, ma'am.
All of you understood nicely? Okay. Now, in between, when it is falling from here to down, it is partially potential and partially kinetic. You agree? See, the circle that I made, four circle, here it is partially potential and partially kinetic. You agree?
Yes, ma'am.
Yes. At top, it is fully potential. At bottom, it is fully kinetic. But in between, when the ball was falling down, you take any point, it is partially potential and partially kinetic. Any problem? Hope you have understood.
No, ma'am.
Huh? No. Who said no, beta? Fazil? Is that you?
Yes, ma'am.
Is that you? You said no, you did not understand?
Yes.
Okay, fine. But do you understand what is potential energy and kinetic energy? Yesterday I taught. Were you present in my lecture?
Yes, ma'am.
Uh, so,
Yes.
okay, I do it again. When I ask you, please give me an answer. Okay?
Okay, ma'am. Okay.
Now I'm holding a ball over here. It's for all of you, beta. If you can explain to Fazil, I welcome you all. Okay? Any of you, Saheem, Abdul, Rizvi, any of you can explain to Fazil. Now I'm holding a ball. It is not moving better. What is the maximum energy?
Potential energy.
Got it? I leave it. I release the ball. It starts falling down. You agree? It starts
Yes.
falling down. Yes? Okay. Now here is the ground. This is the ground. The energy is getting converted. You agree or not?
Yes, ma'am.
Potential energy is getting converted because the ball is moving. So anything which moves will have which energy?
Kinetic energy.
You agree? Kinetic energy. So the potential energy is maximum over here at the top. The ball starts falling down. The potential energy is getting converted to kinetic energy. So what is happening? The potential energy is reducing and kinetic energy is increasing. All of you agree? Hello?
Yes, miss.
Yes? So here minimum will be potential energy and maximum will be kinetic energy. Here is minimum kinetic energy. That means kinetic energy is absolutely zero. Hope you have understood. Now, while it is falling down, for example, let's take this case. It is a mixture of potential energy and kinetic energy. Agree?
Yes, ma'am.
Less potential energy and more kinetic energy. As you go down, the kinetic energy is increasing and potential energy is decreasing. This is what I have taught you.
Okay, ma'am.
Now, did you understand?
Yes, ma'am.
So what is happening is the maximum potential energy is getting converted to maximum kinetic energy when it strikes the floor. When it falls on the ground, the whole potential energy got converted to kinetic energy. Is it clear? And when it stops, when the ball stops rolling, when the ball comes to standstill or comes to rest, again it becomes potential energy. Hope you understood. Till
Yes,
the
ma'am.
body moves, till the body moves, it is kinetic energy. As soon as it comes to a stop, it becomes potential energy. This thing you should keep it in mind. Whether I'm holding the ball, whether the ball has come to rest on its own onto the floor or onto the ground, if it is not moving, it is potential energy. If it is moving, it is kinetic energy. Keep that in your mind forever. You never go wrong. Understood or not? Now there are two ways. Either I'm lifting the ball from the floor or I'm throwing the ball upwards or I'm throwing the ball, I'm keeping the ball in my hand and I'm releasing it. So from top it's coming down. So there are two ways of having potential energy and kinetic energy. Either you throw it upwards or you throw it down. Is it clear?
Yes,
This is how I've shown you, like this. I will try to show it to you. Now, this boy, person, he is throwing the ball upwards. See, it is going up. Yes or no? He's throwing the ball upwards, isn't it? Or there's the ball, it is coming down. So there are two ways to have both the energy, kinetic as well as potential. So if I'm holding the ball in my hand and throw it upwards, again in my hand, the energy was potential. As soon as it leaves my hand, the ball goes up, it converts to kinetic energy. You understand?
Yes, ma'am.
Here, this ball will have potential energy, and when it goes up, it changes to kinetic energy. Got it? Okay, and then again it will go here,
Yes.
it will go up, so it will convert to kinetic energy. Yes. What is written over? I will show you the activity later. Can you see this activity? It's sort of a pendulum. Yes. Look at the hand. It is what it is doing. It is holding this pendulum and it is pulling back. Can you see this? It is pulling back and then it releases. So it starts swinging. What do you say? So it gets this pendulum over here and then it leaves. See? The hand is gone. And then it starts swinging like this. Got it? It starts swinging like this. For making a swing, obviously you have to hold the pendulum and bring it to the extreme position and then release it. So the pendulum starts swinging. Do you follow me? Boys, do you follow me? You're holding this pendulum and you take it to this side and release it. Then it starts swinging like this. Got it?
Yes, ma'am.
So, what is the
Yes.
extreme position? The extreme position are this one and this one. You agree? This is the mean position. The center one is the mean position. But these are the extreme position. Yes? So, what I did, I'm holding the pendulum, the bob rather, and I'm taking it to one side. I'm holding it. See, I'm not releasing. So when I'm holding the pendulum, which energy will be maximum better? When I'm holding it, I'm talking about
Potential.
potential energy. Which will be maximum?
Potential.
Because I'm holding it. It's like I'm holding a ball and I'm releasing it. So I'm here will be the potential energy. This one. This is potential energy. And then I release it. I leave it. So it will come here, it will go here, again it will move, and it will keep on moving. So what happened? The potential energy got converted to kinetic energy and the pendulum starts moving. Did you understand? The
Yes,
movement
ma'am.
will not happen until unless potential energy is converted to kinetic energy. This thing you should remember. If it's potential energy, it will not move. But if it's kinetic energy, yes, it will move. You got it? Yes? Please read.
Potential energy is maximum and kinetic energy is
You
zero
understood now?
at extreme
You understood or
position.
not?
Yes.
All of you? All of you
Yes,
understood?
ma'am.
So potential when I'm holding the ball or the bob or the pendulum, maximum is potential energy. And I release it and then it starts moving. Maximum will be kinetic energy and potential energy will become zero. Hope you have understood. When the body starts moving, potential energy will become zero after some time because it is getting converted to kinetic energy. And kinetic energy will become maximum. Potential energy will be minimum. Hope you have understood. Okay.
Yes, ma'am.
Then what is the second one?
Kinetic energy is maximum and potential energy is minimum at the mean position.
If I call this as the extreme position, this is the extreme. What is maximum? Potential energy. What is minimum? Kinetic energy. And if you take the mean position, what is maximum? Kinetic energy. What is minimum? Potential energy. Understood? Understood? So you
Yes.
get a maximum motion in the mean position. Again, please.
Law of conservation of energy. As energy takes different form and
Changes.
doing changes thing by doing work.
Things. Better be careful, please.
Yes, ma'am. Things by doing work. Nature keeps perfect track of the total. No new energy is created and no existing energy is destroyed.
You understood? What is written? No, please adjust your mic. I'm getting my voice back. Thank you. So I got something new in this slide. So again, I have put it as a part of revision. We see that energy is taking different forms. It is changing from one form to another. What we saw just now, potential energy to kinetic energy and kinetic energy to potential energy. You follow me? So they are doing work, isn't it? The ball is doing work. But how can it do it? It does the work. It does the work by changing the form of energy. So from potential it is becoming kinetic energy. So what is written? We have heard or we have learned that energy is neither created nor destroyed. What is written over here is no new energy is created. That means you are not adding anything to it. From the beginning till the end, whatever energy is present, that is being recorded, nothing else. Neither you add nor you remove. Okay? So it remains the same. What you can see over here, so many types of energy. How it is getting converted to one to another. Let's see. This is potential energy. It is changing to kinetic energy, and kinetic energy is changing to potential energy. You agree? You agree or not? Boys?
Yes, ma'am.
Yes. Then thermal energy changes to kinetic energy. Kinetic energy changes to thermal energy. Thermal is heat. Chemical energy changes to thermal energy. Thermal energy changes to chemical energy. Electrical energy changes to chemical energy. Chemical changes to electrical. Light to electrical. Electrical to light. Pressure to light. Light to pressure. Nuclear to pressure. Pressure to nuclear. So this is how the forms of energy is getting interconverted among themselves. So many types of energy you saw just now. Yes? You getting it now? So we can have so many forms of energy without wastage of energy while transformation. This is known as law of conservation of energy. Any problem whatsoever? Yes? Any problem? Boys, hello? Can you hear me? Boys, can you hear me better?
Yes, ma'am.
Yes, okay. Now we are going to do the last topic of this chapter, that is power. Any problem so far with the slides that we did regarding law of conservation of energy? Do you have any problem in following
No,
it
ma'am.
up? Okay. So now we are going to work on power. So what is power? It is rate of doing work. What is power, beta? Rate of doing work. Please begin. Please start. Please start to read. Hello. Hello. Please start to read. Boys, can you hear me? Hello, boys. Hello.
Yes, ma'am.
Yes, please start reading, beta.
Rate of doing work. Power. Power is the rate of doing work. If W is the work done in time T,
T.
then work done. Power is
No,
equal to
then
work done upon
upon
time taken.
or
Or P is equal to W upon T. The unit of power is watt W. 1 watt is the power of an agent which does work at the rate of 1 joule per second. 1 watt is equal to 1 joule per second, or 1 W is equal to 1 J per
J.
S.
No, J S inverse. S
JS
minus 1 is S
inverse.
inverse. Yes.
1 kilowatt is equal to
Watt.
1000 watt.
Watts, beta. It is not weight.
Watts.
It is watts.
1 kilowatt is equal to 1000 watt. 1 kW is equal to 1000 W. 1 kW is equal to 1000
Joule. Joule
fuel
per second.
per second.
Understood? So you can,
Yes.
what should I say, express in many forms. It's not that whatever is written that only you have to say. No, you can write it like this: joule per second. Yes or no? Either of writing joule as inverse, you can write joule per second. Make it easy, simpler for yourself. Okay, so you can express it in your ways. No problem. Fine. So what is power? It is rate of doing work. We always say, "Na, do you have any power?" We say, right? Don't we say that do you have any power? That means how much work can you do? How fast can you run? So that's why I said, do you have any power? For example, uh, if you're using a remote, then we say, no, oh, it's not working. It does not have power. That means it cannot work. What is the work? That it cannot switch on the TV. Am I right? Hello? Am I right? So what is the work by the remote? To switch on and switch off the TV. That is the work. And from where is getting the energy? By the cell which we apply, by the cell which we put in the remote. If it is not able to work, then we say it does not have power. So what does that mean? That we have to replace the power of the cell. Yes? Boys, can you hear me better? Hello? Boys, can you hear me?
Yes.
Then why no answer? I'm asking you certain questions, I don't get any answer. So that's why I'm asking you whether you are able to hear me properly or not. So can you give me the answer? So what is work done in time t? That is power. So power is equal to W upon T. And what is the unit? It is watt. Yes? And what is 1 watt? 1 joule per second or joule second inverse. And what is 1 kilowatt? You may know that kilo is 1000. So 1 kilowatt is equal to 1000 watts. So 1 kW is equal to 1000 W. And we also know that watt is joule per second. So instead of watt, we can write joule per second as well. So both are same. These two are same. So instead of watt, we can write joule per second as well. Did you understand this slide? Boys, did you understand?
Yes.
All of you?
Yes.
Hmm? Abdul? Shaheen? Rizvi? All of you understood or not?
Yes, ma'am.
Yes,
Power is
please begin.
defined as the rate of doing work or consuming energy. Or power is defined as the rate of conversion of one form of energy into another form of energy. Power is equal to work done upon time taken. P is equal to W upon T. Power is equal to energy consumed upon time taken. P is equal to E upon T.
Fine. So now in this, we are learning something extra about power. We already know that power is rate of doing work. Now, whenever we are doing any work, what are we doing? We are consuming energy. We are using up energy. Yes? Do you follow me? The remote is using the energy from the power to put on and off the TV. Yes? Yes or no? Hello? Hello?
Yes, ma'am.
Yes? Fine. And when all the energy is consumed from the cell, then it stops working. And what we have to do next? We have to replace the cell in the remote. You agree? So what are we doing? We are supplying the energy for the remote to work. What is the work? Putting on and off the TV. Yes or no? Hello? Hello?
Yes.
Yes. So power is what? It is the rate at which one energy is getting converted into another form of energy. Now what are we doing? We are switching. How do we switch? We press the button. We press the button, isn't it? Now, that is mechanical energy. That is mechanical energy. And what goes? The waves. And it gets converted into electrical energy. Am I right? Hello? How remote works? The energy, the mechanical energy by which we press the button gets converted into electrical energy and it starts. Yes or no? Hello? So one form of energy is getting converted into another form of energy. Power is work upon time, W upon T, or it is also can be defined as energy consumed per unit time as P also can be written as E upon T. So we can write as P is equal to W upon T is equal to E upon T. Is it clear? Boys, is it clear?
Yes, ma'am.
Hello? Yes? Okay. Please read. Please begin. Hello,
Yes, ma'am.
start reading.
Okay. Power is a scalar quantity. SI unit of power is watt. 1 watt is equal to 1 joule per second. 1 watt is the power when 1 joule of work is done in 1 second, or 1 watt is the power when 1 joule of energy consumed 1 second. A kilowatt is equal to 1000 watt, or 1 kW is equal to 1000 W. 1 megawatt is equal to 10 lakh watt, or
1 MW.
1 MW is equal to 10 raised to 6 W. Another unit of power is called horsepower, or HP.
Have
1
you heard of
HP is
this?
equal.
Horsepower?
No.
Have you heard of horsepower, beta? Hmm? So let's see the relation between horsepower and watt. See,
1 HP is equal to 746 watt.
1 horsepower is equal to 746 watt. This is the relation between horsepower and the watt.
It's the power of engine of cars and other vehicles is measured by unit called brake horsepower, which is equal to 1 horsepower. Commercial unit of energy. Commercial unit of or trade unit of energy is kilowatt hour,
Hour,
kWh.
H.
kWh is the amount of electric energy consumed when an electrical appliance is having a power rating of 1 kilowatt is used for 1 hour. 1 kilowatt hour is equal to 1000 watts into 300 3600 seconds.
3600 seconds. Because we what we have done, beta? We are converting kilowatt into watt and hour into seconds. Yes or no?
Yes,
Okay. Then
is equal to 30, 36
36 lakh
lakh
watt
36
second.
lakh
Watt
ws
second.
is watt second is equal to 3.6 into 10 raised to 6
6 joule.
joule.
So this is what you have to remember. Okay. Fine.
Okay.
What is power? It's a scalar quantity. That means only magnitude is involved. The SI unit of power is watt that we have already done. And what is 1 watt? 1 watt is 1 joule per second. That also we know, right? Joule second inverse or joule per second. Got it? This is what we know about. What is 1 watt? It is the power when you do 1 joule of work in 1 second. Or rather, we can say that 1 joule of energy is used up in 1 second. So in both ways you can define power. We also know 1 kilowatt is equal to 1000 watt or kW is equal to 1000 W. But you have learned something new over here is 1 megawatt. That is 10 raised to 6 watt. We are going to know something new about power is the horsepower. So another unit of power we are talking about is horsepower. So how many units have you found out, beta? Watt, joule per second, and what is that? The third one, horsepower, HP. The relation between horsepower and watt is that 1 HP is equal to 746 watt. So where do we use this horsepower? Generally in cars and other vehicles, we are using horsepower. Let's talk about the commercial unit of energy. Whatever energy you're consuming at home, you get that bill, isn't it? You get the electricity bill. Hello, boys. Do you get the electricity bill or not? Boys,
Yes.
yes, you get the electricity bill? Yes. So what is the unit of that bill? That is joule. That is joule. So the commercial unit of energy is kilowatt hour. Every hour, how much energy is being consumed at your place? So how do we convert it as kilowatt hour? What is 1 kilowatt hour? The amount of electric energy consumed whenever you are using TV, refrigerator, or your oven, any electrical appliances that you are using, which is having a power rating of 1 kilowatt. Yes, so obviously you're consuming the energy in kilowatts. For how much time? For 1 hour. For every hour, how much unit you are consuming in kilowatt? That is the that is how your bill comes. It comes as 1 kilowatt hour. Means every hour, how much kilowatt you are consuming. Okay, then monthly bill you get. So what is 1 kilowatt hour? We will convert kilowatt into watt, that is 1000 watt. Hour into seconds, that is 3600 seconds. If we club it, if we total it, the product will be 3.6 into 10 raised to power 6 joule. Okay? Do you understand? And then whatever units, see it is a unit. And whatever, so 1 unit is 3.6 into 10 raised to power 6 joule. And how much ever units if you're consuming, for example, you're consuming 100 units in 1 month, that will be multiplied by 3.6 into 10 raised to power 6 joule. You understand? And then you get the bill. Okay? We'll also see how it is converted. Just as a part of revision, we are going to do it again. Please start. Hello. Hello, boys. Please continue.
Commercial unit of power. The commercial unit of energy is kilowatt hour kWh. 1 kilowatt hour is the energy used in 1 hour at the rate of 1 kilowatt or 1000 joule per second.
Inverse. What you will say, joule per second or joule second inverse? Say it again.
Joule second inverse.
Then
1 kWh is equal to 1 kW into 1h. 1000 volt into 1 hour. 1000 watt into 3600 second is equal to 36
that
36 lakh. 1 kWh is equal to 3.6 into 10 joule.
10 raised to
10 raised to 6 joule. The electrical energy used in homes and industries are expressed kilowatt hour. The electrical energy used during a month is expressed in units. Here, 1 unit means 1 kilowatt hour.
so understood. So 1 unit means 1 kilowatt hour. Have you observed one wrong thing over here? No one noted it. It should be what? Minus 6 or 6. What it should be?
Minus 6.
It should be minus 6 or 6. That's what I'm asking you. Do you know the conversion of first? Tell me. Do you know the conversion better? See, 36 into 10 raised to power 1, 2, 3, 4, 5. Yes or no?
Yes,
This
ma'am.
is how I'm going to do this. Now, what do I do? I have taught you, I think, in 8th standard how to convert it. This purely maths, nothing else. What I will do better? I will do 36 into 10 divide by 10 into 10 raised to power 5 just to make it simpler. Agree? All of you agree, beta?
Yes, ma'am.
Yes? Okay. Now, what I will do? I will take this 10 and put it below 36. Agree? And I will add this. So, what I will get? 36 into 10 raised to 5 plus 1 is how much, beta? 6. And divide by 10. Agree? What is 36 divided by 10? 3.6 into 10 raised to power 6. This is what you get. This 0 you will get and you will get 3.6. Understood or not? What I will do? I will multiply and divide both by 10. The 10 gets added with 10 5. We get 10 6. And when you divide by 10, we get 3.6. This is how you have to solve this. Am I clear? Boys, you want me to redo it again?
No, ma'am.
All of you understand how we got 3.6 and how we got 10 raised to 6?
Yes, ma'am.
So we have finished with this chapter today. I will be sending you the textual questions, beta, and you have to personally now show me your lesson number 11 complete portion in text as well as textual. I'm giving only 2 days. Boys,
Yes, ma'am.
yes, and your internals will be based on that completely. Now you have to show it to me. No follow-up teachers. You have to show to me personally. Is it clear, beta?
Yes, ma'am.
Yes, ma'am.
Thank you. No, I said that you have to